similar tools like CF Engine and Puppet.
Yes.
And what do you think is the best choice? You choose Chef, but how do you compare these three tools?
About 3.5 years ago, I evaluated the different systems, CF Engine, bconfig2, Puppet, Chef, and I found that Chef met our needs the best. It basically, you want to choose a tool that fits your way of working and your team's way of working the best. And so for us, a Chef, for somebody else it would be Puppet or bconfig2. It doesn't matter. It's important that you use a tool like this to manage your infrastructure. Any other questions? All right, let's talk about how we can use Chef to achieve this independence. What we want to do is talk about the concepts, take Chef apart, look at it, what are the different pieces, and then use that to write some configuration, see what it looks like actually. And then once we have the configuration separated, we make sure we keep the application code and the application data separate as well, so we can then deploy them to the cloud to scale. Chef is a very broad topic. I'll just be covering 3 different areas: roles, recipes, and data backs. Roles encapsulate pieces of your infrastructure. You can think about your infrastructure the way it is right now, and you could divide it up by function. Say I have these web servers over here. All these nodes are web servers. These other nodes are load balancers, and they each have specific functions. They also have particular pieces of data. For instance, this listens on port 80. And I want to run Nginx on these nodes. If you think about your infrastructure in this way, you can take these pieces and then be able to mix and match them to create what you need by using these roles. This is an example role. This is exactly what it looks like. A role has a name. This one's called Nginx PHP MySQL. And because this is code, we want to document our code so other people can read it, and so it has a description. This installs and configures Nginx, PHP, and MySQL to work together, so I know exactly what this role is going to do. I have pieces of data that tell me how it's going to go about doing it. For instance, I want MySQL to listen only on local hosts. I don't want it to have any other network connections. And so I say the bind address is going to be 127.0.0.1. This is something I put into the role. I also want to make sure that PHP FPM is installed, because I'm going to be running PHP under FPM. And I know that I'm going to be talking to MySQL, so I make sure the MySQL module is installed as well. At the bottom, we have this run list, which means basically what different things are going to run in order to get the node into this state. We're going to talk about that in just a bit. A run list can consist of recipes or roles. Roles can be nested. This one has recipes to do PHP, MySQL, managing users, etc. It also includes a role, reverse proxy Nginx. Somebody tell me what they think this role might actually do. Reverse proxy Nginx. Anybody? Wild guess.
Configure Nginx as a reverse proxy.
Very good. Configure Nginx as a reverse proxy. See, we name our roles, we give them names to actually mean something. And so we know exactly by looking at it, okay, I'm going to have something configured. I'm going to configure Nginx as a reverse proxy. Recipes, that's what you saw at the bottom there, the run list. Recipes are the actual code that you use to configure that node. They're made up of a couple of different pieces. You have resources, files, users, packages. There are different things that you want to put under configuration management in order to install them, in order to configure them, make sure that they're running. You have attributes. These are those pieces of data that we saw before, like MySQL. Listen, the bind address is 127.0.0.1. These are things that will combine together in order to bring that node into the state that you want it to be in. And recipes are collected in things called cookbooks. A cookbook covers basically one piece of software. There's an Apache cookbook in which all the recipes that are used to configure Apache are collected. There's a PostgreSQL cookbook in which you would collect all your recipes in order to configure PostgreSQL. This is an example recipe. I'm not going to go in too much detail here. It's written in Ruby, which makes writing a DSL, a domain-specific language, fairly easy. You have up here packages that you want to install. They're given by this attribute. You read this out at compile time. A directory, which has a certain owner, a group, a mode, and you want it to create all the parent directories. And at the bottom we have a template. It's another resource. We are able to put a script on there and have variables in that script that get replaced depending on the different attributes that are set for that node. The last Chef concept that we're going to be going over is data bags. Data bag is basically data. That's all it is. It's just a bunch of data about your infrastructure. You can have virtual hosts in data bags. You can have users. You can have databases, so that you know, or you can control which virtual hosts are active on which nodes, which users should be provisioned on which nodes, etc. And this is what a data bag looks like. It's in JSON format, JavaScript object notation, which basically means that anything between two curly braces is an object. You can nest them. You have a colon to separate the key from the value. Anything in quotes is a string. You can have arrays. You can have hashes as well. So whatever fits your way of thinking about this data, you can construct it in JSON format and use that in your recipes. Recipe takes the data from the data bag and creates something on that server. And now that we've written these roles and recipes and put our data in the data bag, how does that actually get onto the server? We use these tools that we went over in the overview to apply the configuration. Knife is the first one. It's the command line tool. Knife talks to the Chef server. It uploads your code that you've written to describe your infrastructure to the server. Knife can also query the status from the server, so you know the status of all your nodes. You can find out if a node hasn't checked in, and then find out why. If Knife doesn't already do something that you would like it to do, it's modular. You can write a plugin. If, for example, Knife did not already communicate with your API, you can write a plugin that would handle that communication. There are already plugins for EC2, for Rackspace, for Joyent. All the major cloud providers are already integrated within Knife. And so you can use Knife to bootstrap your infrastructure. You've written your nodes, you've written your configuration, your roles, you got your data in your data bags, you have your recipes, you have them all uploaded to the Chef server, and now you can talk to your provider through the API and bootstrap your infrastructure. How that happens, the Chef client is a daemon process that runs on the node itself. You can run it as a daemon or as a cron job even that will periodically query the Chef server. It will tell the Chef server, I am this node, tell me my configuration. And then the Chef server will say, okay, you have this and that role, you have this run list, go and do it. And then the Chef client takes that information, expands it out, takes all the variables that you have, all the attributes that you've set, substitutes them in, and writes out the configuration. Now, it writes this into a temporary location, compares it to what is already on the server. Say you've already installed Apache. You don't have to install it again. You've already configured Apache. It doesn't need to be configured again if it corresponds to the configuration that you have in the Chef server. If that information is already stored in configuration management, it will ensure that that information stays the same. Your configuration will not change by somebody going to the node and making an edit by hand. The next run of the Chef client will overwrite that change. Oops. There we go. And so that's how you can bring these nodes into a known state, because everything is controlled by configuration management. You have your attributes, you have your run list, and the Chef client will expand them out and write your configuration the way you need it to be. The second piece of this independence is making sure that you have your application code in a way that you can deploy it to multiple nodes. You already have it checked into a repository, I'm sure, or have it deployed to an artifact server so that you can call it from anywhere, or anywhere that you need to. You have a deployment framework, for example, Rundeck, that will that will be able to take that code out of the artifact server and put it onto your nodes. And then you need a source of truth. In this case, it's Chef. We use Chef as the source of truth for the infrastructure. You know all the nodes, you know the roles, you know exactly what should be on each. And so you tell Rundeck to deploy this package onto the nodes that have this role. And then the data, the application data, depends on your application, of course. If your data is stored as files, you put it into an object store. If you have relational data, you store it in RDBMS. And if you have key value data, you store that in a key value store. Most cloud providers will provide all or some of these types of storage. So in order to be able to move your application from one provider to the other, you describe the infrastructure in Chef, and you keep your data and your code separate, and you're able to tell through your deployment framework where everything should go. Some lessons learned in implementing all of this at work. Takes a bit longer to add OS agnosticism to these cookbooks. Chef is a very vibrant community. Each person has their own way of doing things, and if you find that somebody else's way of doing things doesn't exactly work on your server, then you have to do it a different way, and that takes a while. One of the benefits, though, is that these nodes are bootstrapped very quickly. You can get one up in 2 or 3 minutes. If you'd like to learn more about Chef, there's a URL that they've activated, learnchef.com. There's different ways of doing things than how I described. You can, for example, instead of using a deployment framework, you can write an application cookbook. The application cookbook will actually do those steps for you. Deploy your application how you want it to be, just like you would your infrastructure. And Vagrant is a tool that you can use to set up a virtual infrastructure on your laptop, write all your infrastructure code there, test it out, and then bring that to a cloud provider to do your production, to do your QA environment. And so in order to have this migratable infrastructure, you have to keep those 3 pieces separate. You have to keep your configuration separate from your application code, separate from your application data, and be able to talk to each of those through a configuration management framework.